Okay, our next major focus in class here is going to be what's called work. Alright, and now work in physics is very different from just your general work, right, that you might do if you ever get like a job or something like that, right? So if you work at Dairy Queen, you'd consider that work, okay? But in physics, we have a very strict definition of what work is, okay? And that's because we have defined it as something rather specific, okay? The definition of work in physics is a force that is exerted over a certain distance. That is doing work. Okay, so for instance, if I were to take a really heavy box and push it across the classroom, that would be me doing work. Okay? So if there's no distance involved, if there's no movement, okay, there's no work being done. Now that seems counterintuitive to you, right? If you stand in an elevator holding a box, right, you feel like you're doing work, right? It's hard to hold that box. It takes a lot of energy. That's work, right? No, in physics it's not. You're not moving the box. You're not pushing it or pulling it. You're just carrying it. That is not work. Okay, so sorry to let you all down. That's not how work works in physics. Whew, I just said work a lot. Okay, so there's an equation for work. Okay, and that equation is really simple. Work is a force times a distance. Okay, so those two things, right, are needed. They're in the definition. It's a force exerted over a certain distance. So our equation is going to be force times distance. Okay, our unit for work is not going to be in newtons. It's going to be in joules. Okay, joules is another famous scientist. Generally, units are named after famous scientists, if you haven't figured that out already. Okay, and joules are going to be kilograms squared times just kilograms, my bad. Kilograms times meters squared over seconds squared. All right, and you can break that down a little bit, and you can see where that's coming from, right? If a force is a kilogram meter second squared, and you're multiplying that by another distance, right? You're going to multiply that in, and you're going to get kilograms times meters squared over seconds squared. Right, so as you can see, these units are building off of each other as we add more into them. Okay, they're becoming more and more complex. Right? So let's do two examples. I've got it here on the board. All right, and we're going to kind of explain how we're going to do the problems when they come to work. Okay, so the first one says a man pushes a boulder 20 meters with 10 newtons of force. How much work does that man do? Well, let's use our equation. We have a force, that's 10 newtons, and we have a distance, which is 20 meters. We multiply those things together, we will get the work. 10 times 20, that is 200. Having a brain fart. Alright, so 200, and that'll be in joules. Joules is just a big J like this, and so that would be our answer, 200 joules. That's how much work you do. Okay. In 2, we've got a different one. We got a different kind of problem. We've got Hannah. Okay, Hannah is holding a book up in her hands, kind of like this, right? If you held your hand out like this to put a book on it, that's what Hannah is doing. And she's using 20 newtons of force. How much work is done? Well, let's see here. We've got 20 newtons of force. Is her book moving? Okay, probably, let's just say Hannah's really, really buff. So she's holding that book steady. Okay, it's not quivering and waving around, right? She's holding it. Okay, that's no distance. 0. Okay. What's 20 times 0? That is 0. So she's done 0 joules of work. Okay. Do you understand now maybe a little bit why, okay, work has to have a distance involved? If it is defined as a force exerted over a distance and there is no distance, you're not going to get a number. Okay. So it seems counterintuitive based off of our colloquial conception of what work is. Okay. But in physics, work is very specific. And so if there is no distance, there is no work. Okay? So that's something to remember, right? I'm going to guarantee you right now, if you're in my class, this is going to end up on the test. Okay? There's going to be a problem where there's going to be no distance, and you're going to have to say, oh, there's no work. Alright, so write that one down. It's going to be on a test at some point in your scientific careers. Alright? So this is work. It's a definition that a force is exerted over a distance. Okay, so pushing something or pulling something over a distance. Okay, it has a unit, joules, and an equation, where it equals force times distance. That unit can be broken down into its base units, which we've seen right here, right? This is a Newton, that's meters. They combine to make a joule. And we have two different types of problem we're going to see. We're going to see ones where work is actually calculated because there's a distance involved. And there's going to be some that are, you might say, trick questions because there won't be any distance, and so there won't be any work.